Alright, so what I want to do is I want to compute some basic partials here. So let me look at the function. So I'm going to look at the function f of xy, and this is going to be the function. I'm just looking through the book here, x over y. So this is a function, and this is a function in R3. So we could even probably graph this function if we wanted to. That would be quite simple. To do so would be very ordinary. Let's actually see if we can graph this function right away. Let's see what I'm going to use. Let me go into Google Chrome, and I want to visit Wolfram Alpha, and I want to plot this function. Okay, so www.wolframalpha.com. Okay, so I want to plot the function 3D, plot the function f of xy equals to, what was it? Let's see, x over y. Okay, so x, so I could write f of x y equals x over y, but I don't need to do that. I know that it's just x divided by y, and let's click enter. So Wolfram Alpha is giving me the plot of this function, and I am just going to copy this. I'm going to copy the image, right? So here I am copying the image, and just so that we know what this graph looks like, I'm going to paste it over there. So look what's happening here. So x ranges from -1 to 1, y ranges from -1 to 1, and over here z is ranging. See, z here is ranging from -5 to 5. Okay, so I'm coming here. Let me actually paste this graph here. I'm going to paste this graph here. So I'm pasting this here, just to have it here. Okay, so I'm pasting this. So I have my function graph here pasted there for fun, and now what I want to do is at this point is I want to find the partial of f in respect to x. I want to find the partial. Something strange here. Let me continue working. I want to, okay, yeah, alright, so I want to find the partial of this function with respect to x. So the partial of this function, my pen got too thin suddenly. Let me use, this. It's probably nicer. I want to find the partial of f in respect, okay, to x. So partial, this is the notation for partial here, of f in respect to x. So what that means is that I take this function here and treat y as a a constant, and I'm just going to differentiate x. So the derivative of this in respect to x is just going to be 1 over y. Okay? So that's it. Now what the derivative of the function f, or the partial of f in respect to x, measures is the rate of change along the x-axis, right? So along the x-axis. Now I want to compute the partial of f in respect to y. So the partial of f in respect to y is, well, I am going to treat x as a constant, so this is just going to be x times the derivative of 1 over y. Well, so I have to take the derivative of 1 over y. So what I'm going to do is I'm going to use the so-called quotient rule for that. Now let me remind you of what the quotient rule says. The quotient rule says that if you have, let's say, a quotient, let's say, of g, let's say, over h, and I want to take the derivative of that, right? If I want to take the derivative, g over h prime, this is going to be equal to g prime, the derivative of the numerator function, times h minus h prime, the derivative of the denominator function, times g, and all of this I must divide by the square of the denominator function. Okay, great. So I have to do that with 1 over y. Okay, so the numerator here is just going to be equal 1. So if I take the derivative of that in respect to y, well, I'm just going to get 0, okay, times the denominator function, which is y, okay, and then minus the denominator function's derivative. Okay, this is just going to be 1 times g, right? But g is just 1, so I'm just multiplying this by 1, and I have to divide this by y squared. So really what I end up with here is nothing but negative x over y squared. So really what we have obtained here is, okay, is the partial of f in respect to y is equal to this. Something that we should notice is how easy it was to take the partial of f in respect to x, and how relatively more complicated it was to take the partial of f in respect, okay, to y. Okay, so this is f, not fancy f. I made it look a little fancier than the above. Okay, so that is the story about this. Okay, so now let me actually check whether what I did here is right. Okay, so what I'm going to do is I'm going to go to Wolfram Alpha, and I am going to find the partials of this function. So I am checking now. Okay, so checking solution, checking solutions. Okay, that I did. Rather another solution, but checking the work that I did. Right. All right. So let me go to Wolfram Alpha. So I'm going to, the function is x over y, right, which I was working with over here. Now I'm just going to take 3D plot out of here completely, and now what I am going to do is dx of, oh, what did I do? Sorry. I'm going to do dx, sorry, of this whole thing. The partial of this in respect of this function in respect to x. Look how I am writing it over here in Wolfram Alpha. Let's see what I get. So I'm taking the partial in respect to x of this, and let's see what Wolfram Alpha is going to give me. Okay, look at this over here. So it gave me the notation that I know, which is the partial of the function x over y in respect to x, which is equal to 1 over y. So let me actually copy this. So I'm going to copy this, and then I'm going to come back to where I was working, and so this is what Wolfram Alpha tells me. So edit paste, I'm going to paste this here. So I'm pasting this here. So this is what Wolfram Alpha tells me. Okay, and of course, it is exactly what what I got. Yes. Now what I'm going to do is I'm going to check the partial of f in respect to y. Okay, so let's actually go back here, and I'm just doing it in respect to y. So I just come here and change this into a y, and let's see what I get. Okay, the partial of this function in respect to y, so I just wrote dy of x over y. Let's see what I get here. And what I got is negative x over y squared. And I think that is exactly what I got. Let me actually copy this. I'm copying this image, and I'm going back here, and I am actually going to paste this over here so that I have it for my own record. Okay, so I'm pasting this here. So I'm pasting this, and this is what I got. Okay, and so you see that my answer agrees with Wolfram Alpha. So this is a way in which people can use Wolfram Alpha to check things. Anyway, thank you for watching.